welcome guys to the final talk of both this talk and final talk of the conference itself. And this talk will be given by Mario Annau, who has previously worked in the areas of market risk management, proprietary trading, and research, and is the organizer of the Vienna ARM meetup. He has contributed to various R packaging conference talks and is the part of the R community for several years. His talk highlights some of common problems in data science projects and gives guidance on how collaboration can be improved to facilitate a more data-driven transformation in organizations. So I really do hope you enjoy it, and please give it up for Mario Annau.
Thanks. So thanks for having me here, and special thanks to the committee for organizing this great conference. To me, this is a quite unusual talk. I'm doing normally very technical stuff, but this time I thought the timing is about right to lean a bit back and look at the past projects and see maybe a common theme, which in my opinion is collaboration, not so much on the technical side, but actually more on the social side. And it's actually also kind of interesting that an R guy opened the conference and another R guy closed it, so I'm very happy to be here. So collaborative data science, so if you think about companies who build up data science teams and who want to really produce great results, they normally start to, have some budget and get some people together and hire maybe the best data scientists in the world from the greatest universities, maybe even with some PhDs. And then you just put them together in a room, give them some coffee and maybe something to eat and, of course, some data. And you wait for great results, of course. But, I mean, just speaking of my own experience, because I was no better at all, it's more often the case that, those people start to fight, not really fight, but to discuss about very important stuff, not really which delivers business value, but, what kind of language to use, R, Python, Julia, I don't know, MATLAB, everything. Or what kind of editor to use, or whatever. I mean, and then you're going further, and then you're discussing the stack, and you're discussing what kind of database to use, and you're discussing what kind of model to use. And all those discussions end up in big, fights, and people not working with each other and together, but actually against each other, or everybody just working on parallel streams. And I'm not, blaming this. I was actually part of this. So, in a way, this somehow, needs to be worked out. So, just to go further, why is it so hard, actually? Maybe the main question, of course, is an interdisciplinary field. You've got statistics, you've got programming, you've got scientists who care very much about the methods and not so much about, the code. You've got engineers who care very much about the code, not so much about the methods. And maybe data scientists are just very special people. I don't know. So I'm a data scientist myself, so maybe we are really different. And I recently read a book about moral psychology by Jonathan Haidt. I can really recommend it, which is called The Righteous Mind, Why Good People Are Divided by Religion and Politics. And I just rephrased it a bit. It's called The Righteous Data Mind. It's unfortunately cut off, but why good people are divided between code and statistics. So in a way, it's very important still to collaborate with each other, because you've got nice code reviews, you even got, new ideas maybe, and you can deliver even network effect. So by adding more and more people to your data science team, you maybe even increase productivity, however you would measure that, maybe even exponentially. So it's very important so that if companies build up more and more people in data science teams, that they not only collaborate with each other, but that code and the code bases they build up are really, in a way, reusable. and that you can really build up on this. So of course, this is some kind of, if you think of network effects, by adding more data scientists, you would really like to increase actually the productivity exponentially. And the reality, unfortunately, is that in most of the teams, we see that lots of spaghetti code is produced, lots of parallel developments in different teams, and not so much collaboration after all. So improving network effects is very important, again. So how can we manage the code, and how can we improve communication between the teams? And thinking about code repositories, so if you have a company and you're building up a huge data science code repository, you could also think of the CRAN or CRAN repository, which is the main repository of R, and one of the reasons why R is such a great language, because it's actually the biggest statistical code repository in the world. And you see how people, we have the concept of packages. So in R, you bundle some kind of code in reusable packages, and those packages can also import each other. So this concept is very scalable. It's derived from Debian, from the Linux system, and it's very scalable. So this is actually the CRAN packages produced and published, and so far we even have around 13,000 packages. So this whole thing is growing exponentially. So the main server is actually located in Vienna, and packages are added all the time. So this is a huge success, and a huge collaborative success. And if you think of those packages, I can show you here. It's a nice package graph. So you can zoom in here a bit. And of course, you see maybe the ggplot package and also some other Hadley packages. Also maybe some kind of other packages for forecasting time series and so on. So this whole package universe is a highly interconnected graph. And you can zoom in and see how this is going. And it's very complex. The number of packages is just overwhelming, especially for newcomers who come to this language and you want to think, okay, where can I start first? So, and another interesting part is that most of those packages are actually created by only one author. So, the package universe as such is a highly collaborative effort, but on the package level, most of them are only produced by single authors. So close to 10,000 by single authors, and then under 2,000 we have two authors and so on. But most of them are single authors. And this leads, in a way, to package redundancy. So authors do not really seem to talk to each other, or they have some other psychological barriers, but that's another story. And so there are lots of redundant packages around, which is no problem at all, but it makes it very hard for newcomers to get into the language and to decide which ones should be used and which ones not so. And what I want to highlight is actually two examples. One is for the packages which are used to import or work with Excel files, a very basic use case. And the other one is from my own experience, so that you get to know the view from a package author, why this whole thing is happening. So again, we have this fancy graph, and we see here the package universe of the most, important Excel packages. So it's 5 of them. It's read Excel from Hadley Wickham, for example, OpenXLSX to write Excel files and so on. So we can take a look. So this is GData. Then we have this OpenXLSX. We can also play around with it a bit. Then we have the read Excel. So Hadley managed to have a great, community and lots of reverse dependencies, packages which depend on read Excel. And we got XLSX. And the problem is with this friction, if you're as a newcomer coming to this language, you're faced with, 5 or even more packages which are able to handle Excel files, which is actually a very basic use case. And you even see worse that around those packages, you see some kind of package universes which cluster around those. So it's even harder. So this whole package universe is highly fractioned and is torn apart in many parts. And the funny thing, which also happens from time to time, you have packages which actually unify those Excel packages, so-called wrapper packages, which actually, for example, those two in a way connect Excel as X and G-data. We have the dominance package, which actually connects Excel Connect and G-data. So we have also connector packages which then connect those universes together. But still, it's not really satisfying for a newcomer or very irritating for a newcomer to always decide on which packages to use. So ideally, we would like to have one package in the end, which does the job and works fine for all the use cases. But again, I'm no better. So actually, also, I created some kind of package to work on HT5 files, which is a platform programming language independent file format. I used it by then to store tick data. You can store any data in there. And it's programming language independent, so you can work on this with Python, R, Julia, and so on. And of course, I wasn't satisfied with all the packages around, and I decided to create my own one, of course. And I presented this package then 2 years ago at RN Finance. Was lots of effort creating this package. And what happened 2 months after was an email I got from Holger, who actually wrote me that he created exactly the same package or the same functionality in another package. So what I really appreciated was that he at least talked to me and said, okay, there's something going on. And what I can tell you from my own experience is actually that the psychological barriers which exist if you create something on your own, and then somebody else comes and says, okay, now it's redundant, I've created a new one, are huge. So you always have the tendency to say, no, it's mine. And still, after looking into it, and Holger is a great guy, honestly, I replied, sounds interesting, of course. And we could reuse lots of things, okay, technical jibber-jabber, but it used those new R6 classes, and it was actually a good ideas he's implemented. He did a lot of heavy lifting underneath. And so we merged code bases. So actually what I did is I took the high-level code and we put it onto his lower-level C code, and yeah, it worked out. So we released the package in the end. It's just some example. But it was a hard example for me, because also a learning experience, because I really was resisting to do this. So we merged it a few months later. And what I can tell you, it was a success. So we actually reviewed each other's code. The end product was better. It's very hard to measure this, but it has more features. It's easier to use. And what you can really measure is it's more reused. So this package, in the end, has more downloads and is used by more users. So in this sense, this is the measurable success, and I would invite everybody to, collaborate more and to talk to each other and to authors, because, I mean, they're spread over the whole globe, and to, tell them your ideas, and maybe sometimes it's only a few lines of code which, could be integrated into the package, and so you don't need to create your own. And yeah, I really liked it. I want to share this. Another thing is, and also talking about companies right now, is that this whole thing, I mean, no matter if it's R or Python, those huge package repositories I just showed you work because lots of people share code. And what's also my experience is that most companies go there, just use whatever they find, complain maybe even, but don't share back. So to any company out there, please create some open source GitHub repository and share your code. It's not only great because you even get some feedback from the outside for packages maybe you don't really, which are not part of your secret sauce. But you also maybe even can hire some people because they see that you're a cool company and you're having even an open source code repository. So to sum it up, how can code be managed in a reusable way? Please put it into packages. I'm now speaking about R and Python at least. But yeah, this is how it's done, how you can manage dependencies and make sure that packages can be reused even later. You have continuous code reviews and maybe even a platform like GitHub to have transparent, to share code transparently. And maybe how can teams effectively communicate with each other? So have the right tools and mindset in place, and of course, you can incentivize somehow collaborative efforts and not praise just one data scientist who did all the stuff, because it's always a team. And very important, accept the unexpected. So if hypotheses fail and if something doesn't work out, and very important, open-mindedness. So be driven by the data and not by your own, mindset. And that's the hardest part, I can tell you from my own experience. So, and speaking about collaborative tools, I don't know if you know this guy. It's Linus Torvalds. He's actually managing the biggest code repository in the world, which is the Linux kernel. And he's doing it from his own office. I mean, he's here building up showing his desk. It looks quite the same like mine. And yeah, funny guy, but he's only using Git and email. So it's not really, everybody has his own tools. There are, of course, some newer ones out there, but I mean, every team, you always need to decide how to collaborate, and he's found his style. And it worked out very well for him. So that was it. That's our homepage. Again, I'm Mario Annau, CEO of Quantargo. We are offering trainings and consulting in the data science space. Check out the homepage. And thank you. Everything in this presentation is actually online on GitHub, so you can find the sources and play around with the code and the graphs. And yeah, thank you so much.
As they say, doing what you preach as well. Remind that you can always ask our questions through the link here. So it's dsc.network/QA, capital letters, /Tesla, T is a capital letter. However, we do have some questions here. So in general, remote work seems to increase, is on the rise lately. Is this something that can create additional obstacles to the collaboration of a data science team, or does it just provide more opportunities for further collaboration?
Sorry?
Working remotely.
Working remotely, it depends. In the beginning, I would recommend to work on-site, because just to get to know each other and, maybe remove some kind of, language or whatever barriers, I don't know. But working remotely works very well. I mean, I've just showed the example of Linus Torvalds. He only works remotely, I think, from his own home office. And he has a very specific language, so I wouldn't copy that. But no, that works, of course, and companies also need to adapt to it. So I've just experienced that some of them are, or more the old-fashioned ones, are not so into working remotely. But why not?
Well, thank you. And talking about, let's say, breaking this psychological barrier and then going into this changing of mindsets, as you said, you also do trainings. Do you have any examples of how you can facilitate this changing of the mindset in a data science team?
Yes, I mean, we have actually a module which only focuses on this, so collaboration through Git. We also have a chat, so that people can really even chat with each other during the course. And what we also like is some examples. I also did it in my studies, but I still think it's valid. to create some kind of code and give this kind of code some other guy or from the class and to reuse it. And because the whole thing of, I mean, data science in the end is programming. And what's really important in the end is not to put in many comments or whatever, but in the end, the code needs to be reusable. And this is actually what we also want to emphasize. And so both in the end get credit. So the one whose code is reused and the one who uses the code for the better. So these kind of exercises make sense and should teach people to really work together and have, you know, a common successes.
And speaking also on the trainings that you mentioned here, could you elaborate a bit more on other trainings that you do with, not just with collaborative data science, but in general?
So the trainings are actually on the homepage. We have a bunch of modules. The homepage is brand new, so it's further developed. But we have a bunch of modules here. Most importantly, actually machine learning with R. We also have some kind of cloud with R modules and big data. And so we actually cover most of, so currently just R, but most of the aspects of this language. And yeah, we hope to expand it more. And yeah, please check the homepage and it will get updated quickly till year end for sure. So it's ongoing.
Thank you for this. And also one more thing now to, let's say, conclude a bit. From your speech, open-mindedness is quite a big thing with collaboration and collaborative data science. But what other traits as a data scientist do you think are the most important ones to further upon this collaboration and then to collaborate more together?
What are the traits? Or?
Yes, traits.
Yeah. Yeah, it's a good question. In the end, it all boils down to still be in the game and to make more and more experiences and to, I mean, in the end, what we teach people is to reuse the knowledge on a daily basis. So it doesn't make any sense to go to the trainings and then just hear, okay, I need to collaborate and do whatever, but to really, you know, have some constant learning experience. And we also put in more and more examples there. But yeah, just to, you know, have a public GitHub repository maybe and to really enjoy working with people around the globe together and to get feedback, which might hurt sometimes even, but which also gets you learning. And we all, also like Hadley Wickham, I know him because I mean, when he created ggplot, for example, everybody said, why do we need it, and so on. And he also, I mean, we all had some great learning curve after us. So, but you need some point to start and need to be motivated and keep going. That's important.
Thank you. And I think on those words, this is the perfect time to conclude this talk as well. So I would like to thank you for giving us this talk, bringing this topic further here. And also on behalf of the conference, I would like to give you the certificate of appreciation for your participation in the conference. So thank you.
Thanks for having me. Thank you.